Good morning, everyone. This is Limuel A. Hernandez from John J. Russell Memorial High School, also known online as Pinoy Math Teacher. Today, we are going to solve problems involving exponential functions, equations, and inequalities. But before we start our discussion, let us first seek the guidance of our Lord. Let us open our hearts to the Lord and pray. We thank you for this new day, Lord. We come to you today asking for your guidance, wisdom, and support as we begin this class. Help us to engage in meaningful discussion, allow us to grow closer as a group, and nurture our bonds. Fill us with your grace, Lord God, as we make decisions. And continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of the truth, for the greater glory of you, and for the service of humanity. We ask these things in your name. Amen. At the end of this module, you are expected to solve problems involving exponential functions, equations, and inequalities. As a gift for his birthday, Noel's mother gave him a box of pastillas. Noel counted his pastillas and found out that there were 24 pieces in the box. He loves pastillas very much, so he ate half of the pastillas on the first day. Then his mother told him that if he eats it at that rate, the pastillas will only last one more day. So Noel devised a clever plan. He will always eat half of the pastillas that is left in the box each day. He thinks that through this way, he can eat pastillas every day and never run out. How much pastillas does Noel have at the end of the week? Will the pastillas really last forever? Let's make a table of values for this problem. You can see that if Noel eats half the pastillas each day, then by the end of day 1, he only has 12 pastillas in the box. Day 2, 6. Day 3, 3. Day 4, 1.5. Day 5, 0.75. Day 6, 0.38. And by the end of the week, he only has 0.19 pastillas in the box. So, will Noel's pastillas last forever? Theoretically, there will always be some pastillas left. But Noel will be eating very tiny fractions of a pastillas every day after the first week. This is a situation in which exponential function is being modeled. It follows the formula used in solving for the half-life of radioactive substance, which is y equals y sub 0 times 1/2 raised to t over t. Exponential functions occur in various real-world situations. Some of the most common applications in real life of exponential functions and their transformations are population growth, exponential growth and decay, growth of an epidemic, compound interest, loan interest rates, and depreciation. Now, here are some of the formulas you can use to solve exponential problems. Exponential growth and compound interest are among the real-life applications of exponential functions that I have mentioned. Here is how to deal with these problems. An exponential model for this situation is y equals y sub 0 times 1 plus r raised to t, where y sub 0 is the initial amount, r is the growth rate, and t is the time intervals that have passed. Take a look at some of the following examples. The population of Town A in 2010 was estimated to be 25,000 people with an annual rate of increase of 2.4%. Estimate the population in 2020 to the nearest whole number. We can solve these types of problems using the exponential model y equals y sub 0 times 1 plus rate raised to time, where y is the population in 2020. So this is what we are looking for. Y sub 0, or the initial amount or number, is 25,000 people. Rate equals 2.4%, or in decimal, that is equal to 0.024. Time equals the difference between 2020 and 2010, which is equal to 10 years. Now, let us substitute this given to our formula or exponential model. Alright, this is what we get upon substituting the given data to our formula. Let's use a calculator to figure out what y is. So, 25,000 times 1 plus 0.024 raised to 10. So, approximately equal to 31,691.265, or 31,691 people, rounded off to whole number. Therefore, according to the exponential model that we have used, the estimated population of Town A in 2020 is 31,691. Now, let us use this exponential model in solving problems involving compound interest. You take out a 30,000 pesos loan at a 5% interest rate. If the interest is compounded annually, how much will you owe after 5 years? These words here, compounded annually, are very important when it comes to solving problems involving interest and maturity values. These are the keywords that will help us decide which formula or exponential model to apply. In this case, we use y equals y sub 0 times 1 plus rate raised to time. So, y is the amount you will owe after 5 years. So, this is what we need to know in this problem. Y sub 0, or the initial amount or principal in business mathematics, is equal to 30,000 pesos. This is the amount you take out. The interest rate is 5%, or 0.05 in decimal. And time equals 5 years. Again, let us substitute this data to our formula. Okay, so we have y equals 30,000 times 1 plus 0.05 raised to 5. Let's enter this information into our calculator. So 30,000 times 1 plus 0.05 raised to 5. So that is equal to 38,288.446875, or 38,288.45 pesos, rounded off to 2 decimal places. Therefore, this is the amount you will owe after 5 years at 5% interest rate, compounded annually. Now, I'll show you how to solve situational problems involving depreciation and exponential decay. Depreciation refers to when the value of something goes down over time, while exponential decay is the decrease in a quantity according to the law. You can deal with situational problems that include depreciation, exponential decays, and the likes using this exponential model. So, y equals y sub 0 times 1 minus rate raised to time, where y sub 0 is the initial amount, r is the annual decay rate, and t is the time intervals that have passed. Let's put this into practice in a real-life scenario. The original value of a motorcycle is 78,000 pesos. If it depreciates by 3% each year, Find its value in 4 years. An exponential model for this situation is y equals y sub 0 times 1 minus rate raised to time, where y is the value of a motorcycle 4 years after it depreciates. Y sub 0 is the original amount, which is 78,000 pesos. 3% is the annual depreciation rate, and time equals 4 years. This is what we get when we put the given data into the exponential model. We have y equals 78,000 times 1 minus 0.03 raised to 4. Let's enter the given into our calculator. So 78,000 times 1 minus 0.03 raised to 4. Alright. This is approximately equal to 69,052.84. Thus, the motorcycle's value 4 years after it depreciates by 3% each year is approximately equal to 69,052.84 pesos. The next exponential model we'll look at is the doubling time. The doubling time is the time it takes for a population to double in size or value. It is applied to population growth, inflation, resource extraction, consumption of goods, compound interest, the volume of malignant tumors, and many other things that tend to grow over time. To solve these types of problems, we use the formula y equals y sub 0 times 2 raised to t over t, where y sub 0 is the initial amount, capital letter T is the time it requires to double, and small letter t is the time intervals that have passed. A population of 50,000 people doubles in size every 10 years. Determine the population after 15 years. Round your answer to the nearest whole number. Since the population doubles in size, we use the formula y equals y sub 0 times 2 raised to t over t. Y is unknown. This is the population after 15 years. Y sub 0 is 50,000. Capital letter T is the time it requires to double. So this is 10 years. And for small letter t, it is equal to 15 years. Let's substitute the given data into the exponential model. This is what we get after substituting the given data into our formula. We have y equals 50,000 times 2 raised to 15 over 10. Take note that the unit used in small letter t and capital letter T should always be the same. If not, you need to convert it first. To solve for y, let's enter this info into our calculator. So 50,000 times 2 raised to 15 over 10. Okay, so 141,421.356, or this is approximately equal to 141,421 rounded off to whole number. Next, we have the formula for half-life. The half-life of a radioactive substance is the time it takes for half of the substance to decay. An exponential model for this situation is y equals y sub 0 times 1/2 raised to t over t, where y sub 0 is the initial amount, capital letter T is the time it requires to decay into half, and small letter t is the time intervals that have passed. Suppose that the half-life of a certain radioactive substance is 10 days, and there are 150 grams initially. Determine the amount of substance remaining after 30 days. The word half-life here indicates that the formula that we need to use is y equals y sub 0 times 1/2 raised to t over t. Y is the amount of substance remaining after 30 days. Y sub 0 is the initial amount of substance, so that is 150 grams. Capital letter T is the time it requires for the substance to decay into half, and that is 10 days. Small letter t is the time span for which we are attempting to determine the remaining substance. So t equals 30 days. Substituting the given data into our exponential model gives us y equals 150 times 1/2 raised to 30 over 10. To solve for y, let's enter this info into our calculator. So 150 times 1/2 raised to 30 over 10. Okay, so this is equal to 18.75 grams. Therefore, this is how much substance is left after 30 days. Now, let's use this exponential model to solve the situational problem with Noel's pastillas that I presented earlier. We know that there are 24 pieces of pastillas in the box and that Noel plans to eat half of the pastillas that is left in the box each day. The question is, how much pastillas does Noel have at the end of the week or after 7 days? Using the exponential model y equals y sub 0 times 1/2 raised to t over t, we get y equals 24. So this is the initial amount times 1/2 raised to 7. This is the time interval for which we are attempting to determine the remaining pastillas. And we replace capital letter T by 1 because the rate at which the pastillas reduce to half is just 1 day. Let us solve this using a calculator. So 24 times 1/2 raised to 7 over 1 or 7. So this is equal to 0.1875 or 0.19 rounded off to 2 decimal places. The next set of exponential models I'll show you are 4 situations where an initial amount grows or decays continuously. Continuous compounding is the mathematical limit that compound interest can reach if it's calculated and reinvested into an account's balance over a theoretically infinite number of periods. The difference between compounding and continuous compounding is that regular compounding is calculated over a specific time intervals such as monthly, quarterly, semi-annually, and on an annual basis. Continuous compounding is an extreme case of this type of compounding since it calculates interest over an infinite number of periods. The exponential model that represents this situation is y equals y sub 0 times e raised to r times t, where y sub 0 is the initial amount, e is the base of the natural logarithm, also known as Euler's number, which is approximately equal to 2.71828. R is the continuous annual growth rate, and t is the time interval. Let's put this to the test in a real-life situation. The population of a city in 2009 was 100,500. Assuming that the population increases continuously at a rate of 5% each year, predict the population of the city in the year 2020. The keyword that you should look for is the word like continuously. Having this word in problems such as this tells us that the exponential model that we should use is y equals y sub 0 times e raised to r times t. So y is the population of the city in the year 2020, and y sub 0 is the population of a city in 2009, which is 100,500. The annual growth rate is 5% or 0.05 in decimal. And time equals 2020 minus 2009, or that is equal to 11 years. Substituting the given data into the exponential model gives us y equals 100,500 times e raised to 0.05 times 11. Now, let us use a calculator to solve for y. So, 100,500 times e raised to 0.05 times 11. Alright, so y is approximately equal to 174,192. This is the population of a city in 2020. Now, let's try this formula in situational problems involving compound interest. Suppose your father deposited 15,000 pesos in your bank account at an annual interest rate of 5% compounded continuously. How much will you have in your bank account after 12 years? Okay, so this is compounded continuously, meaning we are going to use y equals y sub 0 times e raised to r times t, where y is the amount of money that you will have in your bank account after 12 years. Y sub 0 is the amount that your father deposited, which is 15,000 pesos. The annual interest rate is 5% or 0.05 in decimal. And time equals 12 years. So let's substitute this to our formula. Okay, so we have y equals 15,000 times e raised to 0.05 times 12. Let's solve for y using a calculator. So 15,000 times e raised to 0.05 times 12. Okay, that is approximately equal to 27,331.78. Therefore, this is the amount that you will have on your bank account 12 years after your father deposited 15,000 pesos. For our last exponential model, this is quite similar to this one. The only difference is that the initial amount decays or reduces continuously. The exponential model that we will use when we are solving situational problems where the initial amount tends to decrease continuously is y equals y sub 0 times e raised to negative r times t, where y sub 0 is the initial amount, e is the base of the natural logarithm, r is the continuous decay rate, and t is for time intervals. Let's use this in a real-life situation. The population of a city is currently 75,000, but changing economic conditions are causing the population to decrease by 1.5% each year. If this trend continues, find the population in 20 years. It says that if this trend continues, that is our keyword. It means that the exponential model that we should use is y equals y sub 0 times e raised to negative r times t, where y is the population in 20 years, y sub 0 is the initial amount or number of people, in this case, 75,000. The population is said to be decreasing by 1.5% each year or 0.015 in decimal. And time equals 20 years. Substituting the given values to our formula, we get y equals 75,000 times e raised to negative 0.015 times 20. Now, let us use a calculator to solve for y. So 75,000 times e raised to negative 0.015 times 20. Alright, this is approximately equal to 55,561. So this will become the city's population in 20 years if the trend continues. The next lesson that I am going to teach you is about solving situational problems involving exponential inequalities. Now, here are the tips in dealing with worded problems involving exponential inequalities. Read carefully and underline keywords. Decide what inequality symbol to use. And write and solve the inequality. Before we start answering situational problems involving exponential inequalities, let us first represent each of the following as an algebraic inequality. number 1. So 10,000 times e raised to 0.05t is at most 50,000. The keywords here are the words at most. It means that the value of 10,000 times e raised to 0.05t should be less than or equal to 50,000. Next, number 2. The sum of 5 raised to x and 2 raised to x is at least 14. Now, the keywords here are the words at least. It means that the value of 5 raised to x plus 2 raised to x should be greater than or equal to 14. Next, number 3. So 3 raised to x is less than 9 raised to x minus 2. This one is easy. Just write that 3 raised to x is less than 9 raised to x minus 2. For number 4, we have 1 over 10 raised to x plus 5 is greater than or equal to 1 over 100 raised to 3x. So we just replace the words greater than or equal to by symbol and last number. So y sub 0 times e raised to 0.2 is at least 10,000. It means to say that the value of y sub 0 times e raised to 0.2 should be greater than or equal to 10,000. Or in symbols, we write it like this. Now, let us solve some problems involving exponential inequalities. How much of an initial investment would you need for it to be worth at least 10,000 pesos if it is compounded yearly at 5% interest over 4 years? First, it says that it is compounded yearly or annually. Second, this problem is about compound interest. So we use the exponential model y equals y sub 0 times 1 plus rate raised to time, where the value of y or the future value is 10,000 pesos. This is the amount 4 years after some specific amount which we do not know yet is compounded yearly at 5% interest. That amount that I am talking about is the y sub 0 or the initial investment. This is the amount that we are looking for. Rate is 5% or 0.05 in decimal. And time equals 4 years. Before we write the inequality symbol, let us first interchange the position of y and y sub 0 times 1 plus rate raised to time in our exponential model. This move is valid since we apply the symmetric property of equality. The reason why I did this is because I find it easier to write the inequality symbol because I just base it on which part of the formula is mentioned first and where is it compared to. It says that how much of an initial investment. So this part is equivalent to y sub 0 times 1 plus rate raised to time, because this is the part that includes y sub 0 or the initial investment. And then it says at least 10,000 pesos. This is where the first part of the statement is being compared. Now, for the inequality symbol, for the right side of the equation to be at least 10,000 pesos, it needs to produce a value that is greater than or equal to 10,000. So we write it as y sub 0 times 1 plus rate raised to time is greater than or equal to y. Okay, let's solve for y sub 0. First, we substitute the given value to the formula. So we have y sub 0 times 1 plus 0.05 raised to 4 is greater than or equal to 10,000. Next, we need to isolate y sub 0. So we divide both sides of the inequality by 1 plus 0.05 raised to 4, leaving us with y sub 0 is greater than or equal to 10,000 over 1 plus 0.05 raised to 4. Using our calculator, we can solve for the value of y sub 0. Alright, so 10,000 over 1 plus 0.05 raised to 4. Okay, so y sub 0 is greater than or equal to 8,227.02, rounded off to 2 decimal places. This is the initial investment that we are looking for. In 4 years, it will become at least 10,000 pesos if invested at 5% annual interest. Let us solve the last problem that I have prepared here. How much of an initial investment would you need for it to be worth at least 10,000 pesos if it is compounded continuously at 5% interest over 4 years? Okay, the keywords are compounded continuously. It means that the exponential model that we are going to use is y equals y sub 0 times e raised to r times t, where y is equal to 10,000 pesos. This is the future value. Y sub 0 is the initial investment. Again, this is what we are going to solve. Rate is 5% or 0.05 in decimal. And time equals 4 years. Using the symmetric property of equality, we interchange the position of y and y sub 0 times e raised to r times t. The left side of the inequality should be at least 10,000 pesos. Therefore, y sub 0 times e raised to r times t is greater than or equal to y. Let us substitute the given values to the formula. Okay, we have y sub 0 times e raised to 0.05 times 4 is greater than or equal to 10,000. Next step, divide both sides of the inequality by e raised to 0.05 times 4. So, y sub 0 is greater than or equal to 10,000 over e raised to 0.05 times 4. Using our calculators, we have 10,000 over e raised to 0.05 times 4. Okay, y sub 0 is greater than or equal to 8,187.31 pesos. This is the initial investment that we are looking for. Notice that this amount is smaller than the amount we get in the previous example where y sub 0 is greater than or equal to 8,227.02 pesos. It means that it is wiser to invest your money to those schemes that uses continuous compounding. Now that I have concluded my lecture, it's up to you to demonstrate what you've learned. Are you ready?